Genetic Roots of Criminality and Violence. Editorial published in Medical Hypotheses 2008, 70, 1092-1102. Genetic evidence that Darwin was right about criminality, nature, not nurture. Riccardo Baschetti. Summary. Darwin maintained that man's behaviors, just as the ones of the lower animals, are not cultural products of learning, but constitute evolutionarily selected innate traits that can be transmitted through biological inheritance. Coherently, Darwin wrote that some elimination of the worst dispositions is always in progress. Malefactors are executed so that they cannot freely transmit their bad qualities. Darwin's evolutionary deterministic views about the innateness of human behaviors and the heritability of criminal tendencies prove genuinely far-sighted. Indeed, the scientific evidence that they are genetically determined became indisputable just in this century, about 120 years after Darwin's death. This article, besides discussing human genetic variation and the genetic basis of prosocial traits, focuses on the recent and mounting evidence that points to genes for antisocial behaviors, genes for criminality, and genes for violence. All of them contribute to discredit further the scientifically untenable cultural dogma claiming that human behaviors reflect nurture, represented by social environments, not nature, in the form of biological factors. Genes for criminality and violence also concur to demolish the ideological dogma espoused by those who assert that criminality is a result of poverty and unemployment. The falsity of that politically biased dogma, as argued in this article, is also demonstrated by the fact that Brazil, despite significant reductions of poverty, socioeconomic disparities, and unemployment during the last 5 years, is facing a spiraling increase in criminal misdeeds, including homicides, which have reached an alarming rate that is nearly 5-fold higher than the already worrying one of the USA. Introduction. Charles Darwin, whose great mind one enabled him to conceive the triumphant one and world-changing theory two of evolution, maintained that the moral sense is innate. Indeed, he roundly wrote as follows: "It can hardly be disputed that the social feelings are instinctive or innate in the lower animals, and why should they not be so in man? Others believe that the moral sense is acquired by each individual during his lifetime. On the general theory of evolution this is at least extremely improbable." 3, p. 98. There is growing scientific evidence that Darwin was right about the evolutionary innateness of the social feelings and the moral sense. 4-6. For example, a study published lately in Nature 7 showed that 6 and 10-month-old preverbal infants have the capacity to evaluate individuals on the basis of social behaviors. 7, thereby supporting the view that such a socially beneficial capacity, which may serve as the foundation for moral thought and action. 7, represents a biological adaptation that is universal and unlearned. 7. Heritability of human behaviors. In accordance with his certitude of the innateness of the moral sense, Darwin also maintained that both good human behaviors and the bad ones are innate and transmitted by inheritance. Indeed, he unambiguously stated that in regard to the moral qualities, some elimination of the worst dispositions is always in progress even in the most civilized nations. Malefactors are executed, or imprisoned for long periods, so that they cannot freely transmit their bad qualities. 3, p. 137. Darwin also pointed out that if bad tendencies are transmitted, it is probable that good ones are likewise transmitted. 3, p. 124. Darwin's genial perception of the biological heritability of good behaviors, which, conversely, were attributed to upbringing and religious precepts by most of his contemporaries, proved quite correct and far-sighted. Indeed, nowadays there is compelling evidence that such socially beneficial traits as altruism and cooperation, which various experimental games demonstrated to be very common in humans, constitute genetically conserved ancestral behaviors that have been transmitted across generations. 4. The recently observed strong evidence in favor of a genetic effect 8 on fairness preferences in the most famous experimental game 8 corroborates Darwin's views about the heritability of good tendencies. His views are also incomparably strengthened by the mounting evidence that there are genes for altruism 9-11, which may well account for the large heritability 12 of prosocial behaviors 12-13, because heritability measures the genetically determined variation around some average behavior 8. Considering that criminal and violent behaviors, unlike prosocial traits, represent a scourge worldwide, it is not surprising that, leaving aside many theoretical papers on the origins of altruism and cooperation there are only a few studies on the heritability of socially beneficial traits, whereas the investigations on the genetic basis of antisocial behavior are far more numerous 13. Their findings demonstrate that Darwin, once again, was right and far-sighted. Indeed, there is now incontestable evidence that criminality and violence are caused by genetically determined heritable predispositions. Antisocial genetic mutations. It has recently been argued that Darwin's greatest contribution to science is that he completed the Copernican revolution by drawing out for biology the notion of nature as a system of matter in motion governed by natural laws. The Copernican and the Darwinian revolutions may be seen as the two stages of the one scientific revolution. They jointly ushered in the beginning of science in the modern sense of the word, explanation through natural laws 14. Rather surprisingly, despite the Darwinian and the scientific revolutions, most intellectuals and even many scientists are still reluctant to accept some inescapable social implications of Darwin's theory of evolution. This theory conveys chance and necessity, randomness and determinism 14, because it is based on the concept of spontaneously arisen variations, mutations, sorted out by natural selection 14, which eliminates the disadvantageous ones. For example, one of these unfavorable variations consists in the recently reported gene variant 15 that causes a genetically determined deficit in learning from errors 16. An important social implication of Darwin's evolutionary theory based on mutation and selection 14 is that human behaviors, including both the socially valuable altruistic traits and the socially condemnable selfish ones, which characterize most criminals, reflect heritable predispositions originated by random mutations. Indeed, as has lately been stressed, gain-of-function mutations were invariably found 10 in highly altruistic persons 10, whereas loss-of-function mutations were invariably found 10 in profoundly selfish individuals 10. In 2006, Cohen aired the following view: Darwin put chance variation at the heart of the dynamics of evolution, and the science of chance variation in all branches of science is, without doubt, the major conceptual advance of the last 150 years. Sorry, Einstein won. This view has indirectly been supported authoritatively by Science in its last issue of 2007, in which human genetic variation 17 was defined breakthrough of the year 1718. A homonymous editorial appropriately emphasized that a flood of scans for these variations across the genome has pointed to genes involved in behavioral traits 18. Although both the view of Cohen and the choice of science are probably shared and approved by most scientists, who are also likely to agree that evolution is the unifying concept of biology and the basis for all modern biological research 19, nevertheless some of them, let alone innumerable intellectuals, not only ignore the evolutionary implication suggesting that criminality reflects antisocial genetic mutations, but even reject Darwin's biologically deterministic explanation for human behaviors. This rejection, however, has to do with ideology 20, not with science, and represents an expression of an old debate, namely, the nature versus nurture controversy 21. Nature versus nurture. As Plomin correctly remarked, behavior has been the battleground for the nature-nurture wars 22 that began more than a century ago. In midlife, Sir Francis Galton was so taken with his cousin Charles Darwin's book on the origins of species that he devoted the rest of his life to consideration of heredity and human behavior 22. Galton coined the convenient jingle of words, nature and nurture, and argued that nature prevails enormously over nurture 22. In the early part of the last century, Galton's view of the importance of nature was influential, but the horrors of the Nazis created a revulsion towards all things genetic 22. After the Second World War, behavioral science was dominated by environmentalism 22, which assumes that we are what we learn. The nature versus nurture controversy, which still constitutes a hotly debated topic, is merely one of the several forms of the very old and ongoing conflict between science and dogmas, which include religious beliefs 6, philosophical tenets 5, and ideological doctrines 4. Science versus ideology. Environmentalism, because of its indirect political support to those who believe in what has been defined ideologically based dogma and taboo 23, namely, the communistic ideas about the influence of education and environment 24, was championed by many intellectuals and politicians. Their ideological views about criminality are epitomized in these words: the roots of crime are in social causes, poverty, racism, and unemployment, that call for social solutions, not biological ones 25. However, as James D. Watson, the Nobel Prize-winning co-discoverer of the DNA molecule, most cogently underscored, past eugenic horrors in no way justify the not in our genes politically correct outlook of many left-wing academics. They still spread the unwarranted message that only our bodies, not our minds, have genetic origins. Essentially protecting the ideology that all our troubles have capitalistic exploitative origins, they are particularly uncomfortable with the thought that genes have any influence on intellectual abilities or that unsocial criminal behavior might owe its origins to other than class or racially motivated oppression 26. Although the current system of capitalism is not perfect 27 and an upgraded version of capitalism is needed 27, only those who are ideologically misled by doctrinaire anti-capitalism 28 can unjustly blame capitalism even for antisocial behaviors. Indeed, these socially destructive traits, being due to innate predispositions, can be found in all societies, including the vehemently egalitarian 29, p. 166 ones, which could hardly be more distant from capitalism. For example, as Boehm tellingly pointed out, in spite of egalitarian inculturation, today's hunter-gatherers still have to use capital punishment and resort to execution of serious deviants 29, pages 166, 167. This indisputably demonstrates that such disliked individuals behave antisocially as a result of their biological predispositions to do so, not because of capitalistic socio-economic inequalities, which are non-existent in the egalitarian communities of today's hunter-gatherers. The case of Brazil. On October 29, 2006, Brazilians cast a vote of confidence for President Luiz Inácio Lula da Silva, granting a landslide victory to the former union leader whose first term was marked by a significant reduction of poverty, minimum wage increases and millions of new jobs 30. As a result, many Brazilians have seen tangible improvement in their lives thanks to Lula's policies, which have lifted some 8 million people out of poverty 31. As pointed out in the Washington Post, poverty rates have dipped since he was elected thanks in part to increased government social spending, lower inflation, and a stable currency 32. Indeed, the Brazilian currency, the real, has gained 60% on the dollar since Lula has been president, which has helped keep prices down. The proportion of the population living in poverty has fallen from about 24% to about 18.5% 33. As recognized by an internal report of the World Bank, in Brazil there have been significant advances against poverty because wealth has been distributed more evenly 34. If the claim that criminality is caused by poverty and unemployment were right, then criminality in Brazil should have lessened thanks to the significant reduction of poverty and millions of new jobs 30. On the contrary, as a clear evidence that the above-mentioned ideological claim is false, the increasing crime on the street 35 provokes growing concerns about deadly violence 36, because the urban violence that is spiraling out of control 37 and the advance of criminality which threatens public order 37 demonstrate that Brazil's public safety policies are in shambles 35. Worryingly, in April 2007, it has been stressed that in January 2007 the murder rate jumped 26% compared with the same month last year 37. In May 2007, Amnesty International said the government's inability to provide security had transformed Brazil's largest cities into a patchwork of violent fiefdoms, and had left poor Brazilians in the crossfire between police and criminals, the victims of stray bullets. 38. Notably, other events that occurred recently in Brazil constitute additional evidence that the ideological dogma claiming that poverty and unemployment account for criminality is patently wrong. Indeed, this dogma blatantly fails to explain why such socially destructive crimes as embezzlement and corruption, which is a global problem. 39 that also affects rich nations. 39, siphons public wealth into private hands. 40, and eats away at the economies of poor countries. 39, are committed by individuals who are far from being poor and unemployed. For example, every member of the Brazilian Congress gets an annual wage and benefits package that exceeds $500,000. 41. Nevertheless, about one-fifth of the members of Brazil's 594-member legislature are being investigated for illegal acts. 42 in the context of what has been defined the most well-documented scandal of corruption in the history of Brazil. 43. Considering that the monthly wage of those members is about 40 times higher than the one of a third of Brazilian workers. 44 and that millions of Brazilians are admirably honest and good citizens despite being poor, it is very hard to credit the ideological claims about poverty as root of criminality. Ideological obstacles. The implausibility of those politically biased claims was already quite evident to objective and rational persons nearly 30 years ago and, therefore, some scientists began conducting research on the possible biological and genetic causes of criminal behaviors, thereby troubling many ideologists and intellectuals, who attempted to suppress that innovative and promising scientific research. 45. In 1995, despite the fact that there was already clear evidence for a genetic role in criminality. 46, as shown by several studies on individuals adopted at an early age. 47 to 52, the above-mentioned ideological dogma prompted some of its advocates to protest against a conference on genetics and crime. 25. This meeting, because of ideological pressures, had been protested, cancelled, rescheduled, and otherwise dogged by controversy ever since it was first planned 3 years earlier. As a further confirmation that ideological dogmas tend to hamper the progress of science, those vociferous protesters demanded to block scientific research on the biological basis of criminality. 25. As one of the conferees correctly remarked, however, if we were to block biological research, then the protesters who came to this conference would have to live with the blood of innocent victims on their own hands, the victims of crime we could have prevented if biological research was allowed to continue. 25. Fortunately, in spite of its ideological and political opponents, that scientific research based on behavioral genetics continued and flourished, thereby allowing scientists to demonstrate that antisocial behaviors, including criminality and violence, are caused, respectively, by genes for antisocial behavioral traits. 53, genes for criminality. 54, and genes for susceptibility to violence. 55. Genes for antisocial behavior. The genetic bases of antisocial behaviors have clearly been demonstrated by several investigations. 47, 53, 56 to 66. In 2007, a study reported significant associations 53 of antisocial traits with some specific genes that are expressions of genetic variation. 53. Another study published in 2007 has been able to demonstrate strong heritable effects on antisocial and aggressive behavior in ethnically and economically diverse samples. 57. Lately, a group of researchers, besides reporting significant heritability 58 of antisocial behavior, identified a single genetic factor influencing antisocial behavior beginning at age 10 through young adulthood. 59. Some investigators have recently explored the well-documented relation between the phenotypes of low IQ intelligence quotient and childhood antisocial behavior. 60 and found that genetic influences common to both phenotypes explained 100% of the low IQ antisocial behavior relation. 60. Other authors reported that genetic risks contribute strongly to population variation in antisocial behavior that emerges in early childhood. 64. as shown by the fact that 82% of this variation was influenced by genetic factors 64. The heritability of these factors may well account for the observed continuities in antisocial behavior across 3 generations 67. Genes for criminality. The scientific evidence showing that genes for criminality do exist derives from many studies 47 to 52, 68 to 74. In 2007, a particular genetic variation has been found to confer an increased risk for criminal behavior 68. This finding confirms the one of a previous study 69, which, in turn, strongly supports the notion 69 that the same genetic variation increases the risk of male adolescent criminal behavior 69. The genetic inheritance of criminality was convincingly demonstrated by a group of Finnish researchers who, in 2002, reported that the risk-odds ratio was increased up to 24-fold for violent crimes, and up to 17-fold for criminality among the offspring of homicide recidivists 70. In view of the impressive heritability of criminality, it is not surprising that a study has lately reported the first evidence of transmission of crime across 3 generations 75. Not only the above-mentioned recent studies, but also many others published previously substantiate the notion that criminality is transmitted genetically. For example, in 1996 Lyons observed that genetic factors, but not the common environment, significantly influenced whether subjects were ever arrested after age 15, whether subjects were arrested more than once after age 15, and later criminal behavior 73. In 1990, it was reported that criminality/delinquency in a biologic parent predicted adult adoptee ASP antisocial personality 47. In 1989, a study found that convicted females appeared to be more genetically predisposed than convicted males, a conclusion based on the finding that female property offenders were more likely than male offenders to have convicted biological, but adopted away, offspring 48. In 1984, a study published in Science reported that a statistically significant correlation was found between the adoptees and their biological parents for convictions of property crimes. Siblings adopted separately into different homes tended to be concordant for convictions, especially if the shared biological father also had a record of criminal behavior 49. A meta-analysis of 3 studies published in 1982 50-52, which explored the inheritance of criminality in 913 women and 862 men adopted at an early age by non-relatives, underlined that most explained variation in petty crime was due to differences between the genetic predispositions of the adoptees 74. Genes for violence. That violent tendencies are genetically determined has clearly been shown by several articles 46, 76-85. Recently, many studies have begun to explore the influence of genetic mutations on brain function 86. In 2006, one of these studies identified neural mechanisms associated with one specific gene epidemiologically associated with risk for violent and impulsive behavior 76. A Dutch kindred with this socially harmful gene, which is the result of a genetic mutation 85, exhibited a pattern of impulsively violent criminal behavior for generations 76. Likewise, another specific gene 79, 82 has frequently been found in persons characterized by recurrent and overt physical violent behavior 79. Moreover, an additional specific gene increases the risk of irritability and direct aggressiveness more than 6 and 10 times 62. Aggressive and non-aggressive antisocial behavior, which are both heritable 80, reflect common and specific genetic factors 77. In 2006, a study in 5-year-old twins found that heritability was around 45% for aggressive behavior 78. Other researchers observed that in childhood, aggressive antisocial behavior was highly heritable and showed little influence of shared environment. The continuity in aggressive antisocial behavior symptoms from childhood to adolescence was largely mediated by genetic influences 81. Just as in the cases of the heritable genes for antisocial behavior and criminality, also transmissible genes for violence may well account for the reported aggressive behavior across 3 generations 87. Inhuman mutants. As Meyer-Lindenberg and co-workers have rightly underscored in a recent article 76, a distinction can be drawn between so-called impulsive reactive and instrumental, goal-directed dimensions of aggression. The instrumental factor has been associated with psychopathy. The genetic data suggest that these two dimensions may be genetically dissociable 76. This same distinction was highlighted formerly by others 88, 89. Considering that the definition of psychopathy itself is quite controversial, no less than the construction of any scale to measure it 90, p16, and that the impulsive dimension of aggression is caused by a specific genetic mutation 76, 85, it seems obvious that what is inappropriately defined psychopathy represents a mere expression of another specific genetic mutation transmissible hereditarily. This view is compellingly supported by the remarkably high heritability 91 of some typical signs of lifelong psychopathy that are under extremely strong genetic influence and no influence of shared environment 91. The term psychopathy, coined to define those peculiar signs, is clearly inappropriate because its suffix pathy, which derives from the ancient Greek word pathos, suffering, and is properly used to define afflictively impairing diseases, such as angiopathy and nephropathy caused by other genetic mutations 92, does not reasonably apply to healthy and unimpaired individuals who are often successful criminals 93, characterized by selfishness, callousness, lack of empathy, unemotionality 94, interpersonal manipulation and social deviance 95. Instead of being called psychopaths 89, these socially destructive individuals, whose homicidal crimes are nearly all, 93.3%, 89 for selfish goals, in cold blood, and with premeditation 89, should more aptly be defined inhuman mutants, a definition that captures both their genetically determined 91, 94, 96 monstrous deviance and their socially revolting inhumanity. The adjective inhuman is not inappropriate, because most humans, unlike those selfish antisocial mutants, still conserve genes for unselfishness, cooperation, and even altruistic self-sacrifice for the common good, for all of which enabled the typically small groups of our ancestors to survive in their harshly savage habitats. For the misleading nature/nurture interplay. As a probable consequence of the widespread cultural dogma that misleads even some scientists to reject biological explanations for human behavior and to prefer the cultural ones, there are many authors who believe that antisocial behaviors, including criminality and violence, reflect the interplay 97 between nature and nurture 97. Their belief, however, is both deceitful and socially detrimental, because this genetic-environmental interaction 84 may explain negligibly transient 59 antisocial behavior at puberty 59 and rare forms of reactive socio-emotional hypersensitivity 98, but fails completely to account for socially devastating planned crimes, such as corruption, robberies, instrumental violence, and premeditated homicides, thereby resulting in the conservation of socially ruinous anti-crime policies, including the Brazilian ones criticized by Amnesty International 38. Most legislators, being generally imbued with cultural and philosophical concepts but unfamiliar with scientific facts, substantially belong to the legions of intellectuals who are unwilling to face the fact that there are genetic influences on behavior 99. This unwillingness, as implied by Watson 26, reflects what he defined politically correct outlook 26, which has to do with philosophy, not with science. Indeed, as has pointedly been stressed, neither the genome nor the brain is conveniently divided into politically correct and incorrect regions 99. Despite their unfamiliarity with science, most legislators are aware that behavioral genetics dismantled their cherished environmentalism. Expediently, therefore, they welcome the scientifically proposed gene-environment interaction, because its vagueness, by allowing them to underplay the role of genes and emphasize the one of environment, enables them to conserve politically correct anti-crime laws that are far more concerned with the well-being of criminals, including cold-blooded murderers, than with the health and lives of their victims. Most incisively, it has lately been written as follows: crime is a consequence of injustice. No. Crime is a consequence of criminals. The injustice of Brazil's social inequities is ghastly. But kidnapping children and torturing people do not serve the larger ends of wealth redistribution. If the country needs a revolution, so be it. But fingernail plucking and ear severing are barbarities that do nothing to balance the scales. 40. Even supposing that poverty and social inequities really constitute unfavorable environmental factors that concur with predisposing genes to produce those barbarities, it would be either patently unreasonable or intellectually dishonest to explain them with the nature/nurture interplay. Indeed, it can plausibly be hypothesized that, at most, just 1 out of 100 poor and disadvantaged individuals kidnaps children, plucks fingernails, severs ears, or commits other similarly hideous crimes. Since no sensible person would honestly invoke the nature/nurture interplay to account for the serious gastrointestinal complaints experienced by just 1 out of 100 hosts who shared and ate a wedding cake, it is unclear why we should invoke that interplay to explain those crimes. Yes, it is unquestionable that, on purely abstract and theoretical grounds, those complaints do reflect the nature/nurture interaction, because they are a consequence of both the biological characteristics of the harmed host and the ingestion of that sweetened nurture, without which they would have not occurred. But it is also indisputable that, practically, the complaints of that single damaged host are to be ascribed entirely to his biological proneness to develop them. Analogously, the genetic predisposition to criminality should be regarded as the unique responsible for the misdeeds of criminals. It is time, therefore, to reject decisively what Brazilian journalists have justly defined the false question of poverty 100 in their article commenting on the relatively privileged socio-economic conditions of armed criminals whose robbery resulted in the consciously perpetrated gradual dismemberment and decapitation of a 6-year-old child. 101. This horrendous murder that was committed a few weeks after a monstrous crime, during which 2 armed robbers killed a 5-year-old child and his parents by burning them alive premeditatedly. 102, prompted another Brazilian journalist to write that Brazil is in the emergency room of a social tragedy in which the bandit decides whom lives and whom dies. 103. This statement is understandable, because in Brazil the rate of homicides is nearly 5-fold higher than the already worrying one of the USA. 104. Nature misinterpreted as nurture. Unfortunately, the cultural dogma, environmentalism, and their politically correlated ideology are still so powerful and common that they misled several researchers to interpret erroneously some effects of genes as consequences of environment, thereby further undermining the credibility of the frequently invoked nature/nurture interplay. For example, the aggressive parenting that results in childhood maltreatment. 105 to 110, which harms behavior ally only children with a special genotype. 111, 112, has been viewed as a deleterious environmental factor that predisposes children to later violent offending. 106, violent delinquency. 105, and adult antisocial and violence-related behavioral problems. 108. All of these violent antisocial behaviors, however, can be explained far more plausibly by the thesis that they have been transmitted genetically, not culturally. If we fail to bear in mind the deceptive effects of the cultural dogma, we cannot but wonder why aggressive parenting 87, 113 across 3 generations, instead of being regarded as a genetically transmitted behavior, has been misinterpreted as a finding consistent with a social learning perspective. 87. Low social status, which leftist ideologues emphatically claim to be an unfavorable environmental factor that is largely responsible for criminality, represents another example of nature misinterpreted as nurture. Indeed, the low intelligence 114 that has consistently been reported to be strongly associated 114 with delinquency 114, antisocial behavior 60, and male criminal violence 115 may well account for the low social status of many criminals, especially the violent ones, whose coarse instrumental aggressiveness reflects their mental inability to use more intelligent criminal strategies for exploiting honest people. Even presupposing the improbable fact that criminals, despite their notorious laziness and propensity to social parasitism, are really intentioned to work. It is obvious that their low intelligence prevents them from obtaining well-remunerated jobs. Indeed, considering that human adults evaluate people rapidly and automatically on the basis of both behavior and physical features. 7. It is unlikely that employers are willing to offer those coveted jobs to individuals whose low intelligence and antisocial inclinations are easily perceivable. It should be emphasized that, just in the case of poverty discussed above, low social status in itself is not associated with criminality. Indeed, an ample study conducted in Sweden found that low social status alone was not sufficient to lead to criminality, but did increase risk in combination with specific types of genetic predisposition. 51. These specific types, however, in the form of genetically determined synergistic combination of low intelligence and tendency to criminality. 60, 114, 115, are the causes of low social status, not its effects. Needless to say, low intelligence alone, too, does not predispose to criminality, as shown by the great number of poorly intelligent persons who are laudably honest and good citizens. It must also be stressed firmly, however, that in multiracial countries, especially in the USA, the low social status of some individuals of ethnic minorities may not be a consequence of low intelligence, but may simply reflect the obtusely preconceived ideas of employers who perpetuate anachronistic and odious discriminations against those groups. Conclusion. In Nature, it has rightly been written that surely, if doctrines were to have health warnings attached to them objectively assessed by the number of individuals they had harmed, the fashionable Marxist belief that the social environment is much more important than anything else would be rated many times more harmful than any acknowledgement of the influence of genes. 116. Indeed, millions of honest citizens have been harmed and killed by criminals after the legislators' espousal of social environmentalism some decades ago. Regrettably, the number of those victims of criminals is unavoidably doomed to rise further, unless policymakers will at least realize and admit that criminality, far from being a consequence of environmental socio-economic factors, is essentially a biological phenomenon that reflects genetically determined antisocial predispositions. As such, criminality, and especially its worst expression, namely, premeditated homicidal violence, should be regarded as a public health problem. 117 and must be prevented with modern policies based on science, not on obsolete ideological dogmas or moral principles invented extemporaneously by philosophers in the last minute of the evolutionary clock. 5, 6. Evolution, not philosophy, originated morality. 5, 6, which explains why most humans, driven by the genetically conserved egalitarian motives. 118, 119 and altruistic behaviors that enabled the small ancestral groups to survive in their hostile surroundings. 4, feel the moral imperative to reduce poverty and socio-economic inequalities. Likewise, most humans, driven by the evolutionary 120, altruistic 119, 120, 122, neurobiological 121, 122 punitive instinct that enabled those small hunter-gatherer groups to prevent their extinction by executing socially destructive deviants. 29, also feel the moral imperative to use capital punishment for reducing the cold-bloodedly premeditated assassinations of countless honest citizens, including innocent children. 117. References. 1. Cohen J.E. The Evolution of a Great Mind, The Life and Work of Darwin. Lancet 2006, 367, 721-2. 2. Mullen R. A Biography of Darwin's Big Idea. Lancet 2007, 369, 1252. 3. Darwin Cr. The Descent of Man and Selection in Relation to Sex. John Murray, London, 1875. Illiberan Classics Replica Edition. Adamant Media Corporation, 2005. 4. Baschetti R. Evolutionary, Neurobiological, gene-based solution of the ideological puzzle of human altruism and cooperation. Med Hypotheses 2007, 69, 241-9. 5 Baschetti R. The Dawn of Science-Based Moral Reasoning. Med Hypotheses 2007, 68, 4-8. 6 Baschetti R. Evolutionary, Biological Origins of Morality, Implications for Research with Human Embryonic Stem Cells. Stem Cells Dev 2005, 14, 239-47. 7 Hamlin J.K., Wynne K., Bloom P. Social Evaluation by Preverbal Infants. Nature 2007, 450, 557-9. 8 Wallace B., Cesarini D., Lichtenstein P., Johannesson M. Heritability of Ultimatum Game Responder Behavior. PROC Natal Academic Sci USA 2007, 104, 15631-4. 9 NAFOA, Israel S., Darvez IA, ETAL. Individual differences in allocation of funds in the dictator game associated with length of the arginine vasopressin 1 a receptor Rs3 promoter region and correlation between Rs3 length and hippocampal mRNA. Genes Brain Behave, in Press. 10 The International Alt/Self Map Consortium. A same gene for altruism and selfishness in primates. MedSci, Paris, 2007, 23, 440-4. 11 Bachner Melman R., Gritsenko I., Nemanov L., Zohar A., Dina C., Epstein R.P. Dopaminergic polymorphisms associated with self-report measures of human altruism, a fresh phenotype for the dopamine D4 receptor. Mole Psychiatry 2005, 10, 333-5. 12 NAFOA, Plomin R. Processual Behavior from Early to Middle Childhood, Genetic and Environmental Influences on Stability and Change. Dev Psychol 2006, 42, 771-86. 13 Rushton J.P. Genetic and Environmental Contributions to Prosocial Attitudes, a Twin Study of Social Responsibility. PROCRSOC London B. Bile Sci 2004, 271, 2583-5. 14 Ayala F.J. Darwin's Greatest Discovery, Design Without Designer. PROC Natal Academic Sci USA 2007, 104, Sup 18567-73. 15 Holden C. Gene variant may influence how people learn from their mistakes. Science 2007, 318, 1539. 16 Klein Ta, Newman J., Reuter M., Hennig J., von Kramon D.Y., Ulsperger M. Genetically determined differences in learning from errors. Science 2007, 318, 1642-5. 17 Panacea Breakthrough of the Year, Human Genetic Variation. Science 2007, 318, 1842-3. 18 Kennedy D Breakthrough of the Year. Science 2007, 318, 1833. 19 Hansen R.B., Bloomfay. Fending Off Furtive Strategies. Science 1999, 285, 1847. 20 More W.K. Discarding Ideology, The Nature/Nurture Endgame. Perspect Psychiatricare 2003, 39, 113-21. 21 Stimmel B. The Role of Ethnography in Alcoholism and Substance Abuse, The Nature versus Nurture Controversy. ADV Alcohol Substance Abuse 1984, 4, 1-8. 22 Plomin R. Genes and Behavior. ANMED 1995, 27, 503-5. 23 Butler D. Geneticist quits in protest at Genes and Violence claim. Nature 1995, 378, 224. 24 Hagenboom M. Nature via Nurture, Genes, Experience, and What Makes Us Human. BMJ 2003, 326, 1402. 25 Rausch W. Conflict Marks Crime Conference. Science 1995, 269, 1808-9. 26 Watson J.D. Genes and Politics. Jamol Med. 1997, 75, 624-36. 27 Costanza are avoiding system failure. Nature. 2007, 446, 613-4. 28 Charlton B.G. Health Equity for All, Capitalism is a Force for Good. BMJ 2007, 335, 628-9. 29 Boehm C. The Origin of Morality as Social Control. Response to Commentary Discussion. In, Katz LD, Editor. Evolutionary Origins of Morality, Cross-Disciplinary Perspectives. Thorverton, UK, Imprint Academic, 2000. p. 149-83. 30 Real M. Brazilian President wins second term sizable margin, advocate for poor overcame scandals. The Washington Post, October 30, 2006, 8:12. 31 Editorial. Victory for Lula, Brazil's president earns a second term, but will he make good use of it? The Washington Post, October 31, 2006, 8:20. 32 Real M. Brazil's Lula forced to a runoff in re-election bid, president wins first round vote but falls short of majority needed for outright victory. The Washington Post, October 2, 2006, A14. 33 Real M. Support from Brazil's poor gives Lula edge in election. The Washington Post, October 1, 2006, A19. 34 Goodman P.S. The Persistently Poor, an internal report criticizes World Bank's efforts on poverty. The Washington Post, December 8, 2006, D1. 35 Astor M19 killed as gangs attack buses, police posts around Rio de Janeiro. The Washington Post, December 29, 2006, 8:20. 36 Real M19 killed as police battle drug gangs in Rio, shootouts add to alarm over city's violence. The Washington Post, April 19, 2007, 8:22. 37 Hennigan T. Marvelous City seeks Army help to end its daily bloodshed. The Times, April 13, 2007. 38 Anonymous. World in Brief. The Washington Post, May 3, 2007, 8:20. 39 Donahue P. Corruption Watchdog downgrades U.S. The Washington Post, November 8, 2006, 8:25. 40 Kennicott P. Mandabala, Corruption's Human Toll. The Washington Post, September 28, 2007, C05. 41 Downey A. Lula vs. Congress in Brazil. Time, February 1, 2007. Available from www.time.com/time/world/article/0,8599,1584152,00.html, 2007. 42 Real M. Lula silence only makes Brazilian public grow fonder, President shuns debates and press in re-election campaign. The Washington Post, August 27, 2006, A14. 43 Carneiro M. Arapire Duque se Pensiva. It was worse than what they thought. In Portuguese. Veja 2006, 29, 56-63. 44 Anonymous. Brazil, minimum wage to rise. The Washington Post, December 28, 2006, D3. 45 Wilson E.O. The Attempt to Suppress Human Behavioral Genetics. J. Gen Educ 1980, 29, 277-87. 46 Delilah L.F., Gottesman 2. Biological and Genetic Contributors to Violence, Whittam's Untold Tale. Psychol Bull 1991, 109, 125-9. 47 Cataret R.J., Troughton E., Bagford J., Woodworth G. Genetic and Environmental Factors in Adoptee Antisocial Personality. Your Arch Psychiatry Neurol Sci 1990, 239, 231-40. 48 Baker L.A., Mac W., Moffat T.E., Mednick S. Sex Differences in Property Crime in a Danish Adoption Cohort. Behov Genet 1989, 19, 355-70. 49 Mednick S.A., Gabrielli J.R.W.F., Hutchings B. Genetic Influences in Criminal Convictions, Evidence from an Adoption Cohort. Science 1984, 224, 891-4. 50 Bowman M., Cloninger C.R., Sigvardsson S., von Noring A.L. Predisposition to Petty Criminality in Swedish Adoptees. Genetic and Environmental Heterogeneity. Archgen Psychiatry 1982, 39, 1233-41. 51 Cloninger C.R., Sigvardsson S., Bowman M., von Noring A.L. Predisposition to Petty Criminality in Swedish Adoptees. 2 Cross-fostering Analysis of Gene-Environment Interaction. Archgen Psychiatry 1982, 39, 1242-7. 52 Sigvardsson S., Cloninger C.R., Bowman M., von Noring A.L. Predisposition to Petty Criminality in Swedish Adoptees. 3 Sex Differences and Validation of the Male Typology. Archgen Psychiatry 1982, 39, 1248-53. 53 Pritchard Z. M., Horm A. F., McKinnon A., Eastiel S. Association Analysis of 15 Polymorphisms within 10 Candidate Genes for Antisocial Behavioral Traits. Psychiatry Genet 2007, 17, 299-303. 54 Savulescu J. Why Genetic Testing for Genes for Criminality is Morally Required. Prince A. J. Bioeth 2001, 4, 79-97. 55 Viding E. Frith U. Genes for Susceptibility to Violence Lurk in the Brain. PROC Natal Academic Sci USA 2006, 103, 6085-6. 56 Larson H., Tubblad C., Reisdijk F.V., Andershed H., Gran M., Lichtenstein P. A common genetic factor explains the association between psychopathic personality and antisocial behavior. Psychol Med 2007, 37, 15-26. 57 Baker L.A., Jacobson K.C., Rain A., Lozano D., Bis GNS Genetic and Environmental Bases of Childhood Antisocial Behavior, a Multi-Informant Twin Study. J. Abnorm Psychol 2007, 116, 219-35. 58 Moss H.H., Silberg J.L., Neal M.C., Eves L.J. Genetic and Cultural Transmission of Antisocial Behavior, an Extended Twin Parent Model. Twin Residential Hum Genet 2007, 10, 136-50. 59 Silberg J.L., Rutter M., Tracy K., Moss H.H., Eves L. Ideological Heterogeneity in the Development of Antisocial Behavior, the Virginia Twin Study of Adolescent Behavioral Development and the Young Adult Follow-Up. Psychol Med 2007, 37, 1193-202. 60 Cohen K.C., Caspi A., Moffat T.E., Reisdijk F., Taylor A. Genetic Influences on the Overlap Between Low IQ and Antisocial Behavior in Young Children. J. Abnorm Psychol 2006, 115, 787-97. 61 Moffat T.E. Genetic and environmental influences on antisocial behaviors, evidence from behavioral genetic research. ADV Genet 2005, 55, 41-104. 62 Garagi, Garofano L., Pellegrini C., ETAL Allelic association of a dopamine transporter gene polymorphism with antisocial behavior in heroin-dependent patients. Addict Bile 2005, 10, 275-81. 63 Malone S.M., Taylor J., Marmerstein N.R., McHugh M., Iacono W.G. Genetic and environmental influences on antisocial behavior and alcohol dependence from adolescence to early adulthood. Dev Psychopathol 2004, 16, 943-66. 64 Arsenault L., Moffat T.E., Caspi A., ETAL Strong genetic effects on cross-situational antisocial behavior among 5-year-old children according to mothers, teachers, examiner observers, and twin self-reports. J. Child Psychiatry 2003, 44, 832-48. 65 Slutsk W.S. The Genetics of Antisocial Behavior. Psychiatry Rep 2001, 3, 158-62. 66 Goldstein R.B., Prescott C.A., Kendler K.S. Genetic and environmental factors in conduct problems and adult antisocial behavior among adult female twins. J. Nerve Mentis 2001, 189, 201-9. 67 Smith C.A., Farrington D.P. Continuities in antisocial behavior and parenting across 3 generations. J. Child Psychiatry 2004, 45, 230-47. 68 Schoberg R.L., Nilsson K.W., Wargelius H.L., Lepper J., Lindstrom L., Orland L. Adolescent Girls and Criminal Activity, Role of MAOALPR Genotype and Psychosocial Factors. AMJ Met Genet B. Neuropsychiatry Genet 2007, 144, 159-64. 69 Nilsson K.W., Schoberg R.L., Damerg M., ETAL Role of monoamine oxidase A genotype and psychosocial factors in male adolescent criminal activity. Biopsychiatry 2006, 59, 121-7. 70 Putkanen A., Rine N. Op., Aronen M., Tyahanan J. The Quantitative Risk of Violent Crime and Criminal Offending, a case control study among the offspring of recidivistic Finnish homicide offenders. Acta Psychiatriscan Supl. 2002, 412, 54-7. 71 Taylor J., Iacono W.G., McHugh M. Evidence for a Genetic Etiology of Early Onset Delinquency. J. Abnorm Psychol 2000, 109, 634-43. 72 Gotts M.J., Johnstone E.C., Ratcliffe S.G. Criminality and Antisocial Behavior in Unselected Men with Sex Chromosome Abnormalities. Psychol Med 1999, 29, 953-62. 73 Lyons M.J. A Twin Study of Self-Reported Criminal Behavior. SIBO found SYMP 1996, 194, 61-70. 74 Bowman M. Predisposition to Criminality, Swedish Adoption Studies in Retrospect. SIBO found SYMP 1996, 194, 99-109. 75 Putkanen A., Rine N. Op., Aronen M., Tyahanan J. Transmission of Violent Offending and Crime Across 3 Generations. SOC Psychiatry Psychiatry Epidemial 2007, 42, 94-9. 76 Meyer Lindenberg A., Buchholz J.W., Kolachana B., ETAL Neural Mechanisms of Genetic Risk for Impulsivity and Violence in Humans. PROC Natal Academic Sci USA 2006, 103. 6269-74. 77 Gellhorn H., Stallings M., Young S., ETAL Common and Specific Genetic Influences on Aggressive and Non-Aggressive Conduct Disorder Domains. JAM Academic Child Adolescent Psychiatry 2006, 45, 570-7. 78 Polderman T.J., Posthumati, Desonville L.M., Verhulst F.C., Bumsmede. Genetic Analyses of Teacher Ratings of Problem Behavior in 5-year-old Twins. Twin Residential Hum Genet 2006, 9, 122-30. 79 Retz W., Retz Junging P., Cyprian T., Thome J., Rosil M. Association of Serotonin Transporter Promoter Gene Polymorphism with Violence, Relation with Personality Disorders, Impulsivity, and Childhood ADHD Psychopathology. Behavsci Law 2004, 22, 415-25. 80 Button T.M., Scourfield J., Martin N., McGuffin P. Do aggressive and non-aggressive antisocial behaviors in adolescence result from the same genetic and environmental effects? AMJ Met Genet B Neuropsychiatry Genet 2004, 129, 59-63. 81 Elitc, Lichtenstein P., Moffat T.E. A longitudinal behavioral genetic analysis of the etiology of aggressive and non-aggressive antisocial behavior. Dev Psychopathol 2003, 15, 383-402. 82 Lesk KP, Merschderview Impulsivity, Aggression, and Serotonin, A Molecular Psychobiological Perspective. Behavsci Law 2000, 18, 581-604. 83 Elitc, Lichtenstein P., Stevenson J. Sex Differences in the Etiology of Aggressive and Non-Aggressive Antisocial Behavior, Results from 2 Twin Studies. Child Deb 1999, 70, 155-68. 84 Cataract R.J., Yates W.R., Troughton E., Woodworth G., Stewart Ma. Genetic Environmental Interaction in the Genesis of Aggressivity and Conduct Disorders. ArchGen Psychiatry 1995, 52, 916-24. 85 Brunner H.G., Nellen M., Brakefield X.O., Ropers H.H., Van Oost B.A. Abnormal behavior associated with a point mutation in the structural gene for monoamine oxidase A. Science 1993, 262, 578-80. 86 Mata EVS, Goldberg T.E. Imaging Genetic Influences in Human Brain Function. Kuropin Neurobile 2004, 14, 239-47. 87 Conger R.D., Nepal T., Kim K.J., Scaramella L. Angry and Aggressive Behavior Across 3 Generations, A Perspective, Longitudinal Study of Parents and Children. J. Abnorm Child Psychol 2003, 31, 143-60. 88 Blair R.J.R. Neurocognitive Models of Aggression, the Antisocial Personality Disorders, and Psychopathy. J. Neural Neurosurg Psychiatry 2001, 71, 727-31. 89 Woodworth M., Porter S. In Cold Blood, Characteristics of Criminal Homicides as a Function of Psychopathy. J. Abnorm Psychol 2002, 111, 436-45. 90 Garland B., Editor. Neuroscience and the Law, Brain, Mind, and the Scales of Justice. Washington, D.C., Dana Press, 2003. 91 Viding E., Blair R.J., Moffat T.E., Plomin R. Evidence for Substantial Genetic Risk for Psychopathy in 7-year-olds. J. Child Psychol Psychiatry 2005, 46, 592 to 7. 92 Plaisir e, Gribavalo, Alamo which s, ETALCOL4A1 mutations and hereditary angiopathy, nephropathy, aneurysms, and muscle cramps. An English JMed 2007, 357, 2687 to 95. 93 Ishikawa SS, Rain A, Lynch T, Veer S, Lacasa L. Autonomic stress reactivity and executive functions in successful and unsuccessful criminal psychopaths from the community. J. Abnorm Psychol 2001, 110, 423 to 32. 94 Larson H, Andershed H, Lichtenstein P. A genetic factor explains most of the variation in the psychopathic personality. J. Abnorm Psychol 2006, 115, 221 to 30. 95 Linum Dr., Caspi A, Moffat T. E., Rain A, Lober R., Stouthammer Lober M. Adolescent psychopathy and the Big Five, results from 2 samples. J. Abnorm Child Psychol 2005, 33, 431 to 43. 96 Blair R.J., Pescard K.S., Budhani S., Mitchell D.G., Pine D.S. The Development of Psychopathy. J. Child Psychol Psychiatry 2006, 47, 262 to 76. 97 Videing E. On the Nature and Nurture of Antisocial Behavior and Violence. An NY Academic Sci 2004, 1036, 267 to 77. 98 Eisenberger N.I., Weiby M., Taylor S.E., Welch W.T., Lieberman M.D. Understanding Genetic Risk for Aggression, Clues from the Brain's Response to Social Exclusion. Bile Psychiatry 2007, 61, 1100 to 8. 99 Touchet and Genetics and Crime Conference reap subtle benefit. Nature Med 1995, 1, 1108 to 9. 100 Soares R., Franca R. A Falsa Questão da Pobreza, The False Question of Poverty. In Portuguese. Veja 2007, 7, 46 to 7. 101 Real M. In Rio, death comes early, juveniles are often victims as gangs, police vie for control of slums. The Washington Post, April 16, 2007, A01. 102 Linhers J. O Pier de Todos os Pesadelos. The Worst of All Nightmares. In Portuguese. Veja 2006, 50, 148 to 51. 103 Bortolati M. Sem limites para a barbari, Without Limits for Barbarity. In Portuguese. Veja 2007, 6, 46 to 51. 104 Wikipedia. List of countries by homicide rate. Available from http://www.en.wikipedia.org/wiki/list_of_countries_by_homicide_rate, 2007. 105 Mirsky J.P., Reynolds A.J. Child Maltreatment and Violent Delinquency, Disentangling Main Effects and Subgroup Effects. Child Maltreat 2007, 12, 246 to 58. 106 Hosser D., Raditz S., Winzio M. Child Maltreatment, Revictimization, and Violent Behavior. Violence Vic 2007, 22, 318 to 33. 107 Lansford J.E., Miller Johnson S., Berlin L.J., Dodge Ka, Bates J.E., Pettit G.S. Early Physical Abuse and Later Violent Delinquency, a Prospective Longitudinal Study. Child Maltreat 2007, 12, 233 to 45. 108 Huizinga D., Haberstick B.C., Smolin A., ETAL Childhood Maltreatment, Subsequent Antisocial Behavior, and the role of monoamine oxidase A genotype. Biopsychiatry 2006, 60, 677-83. 109 Smith CA, Ireland 2, Thornberry TP Adolescent Maltreatment and its Impact on Young Adult Antisocial Behavior. Child Abuse Nickel 2005, 29, 1099-119. 110 Tremblay Re, Nagin DS, Seguin Jr., ETAL Physical Aggression During Early Childhood, Trajectories and Predictors. Pediatrics 2004, 114, E43, 50. 111 Caspier, McClay J., Moffat T.E., ETAL Role of Genotype in the Cycle of Violence in Maltreated Children. Science 2002, 297, 851-4. 112 Jaffe S.R., Caspier, Moffat T.E., ETAL Nature x Nurture, Genetic Vulnerabilities Interact with Physical Maltreatment to Promote Conduct Problems. Dev Psychopathol 2005, 17, 67-84. 113 Hops H., Davis B., Leaves C., Schieber L. Cross-generational transmission of aggressive parent behavior, a prospective, mediational examination. J. Abnorm Child Psychol 2003, 31, 161-9. 114 Kohlhoff R., Lober R., Weah, Pardini D., DSQRAC Inhibition Deficits of Serious Delinquent Boys of Low Intelligence. Crimbihab Ment Health 2007, 17, 274-92. 115 Heilbrunn J. Arab. Differentiation of death row murderers and life sentence murderers by antisociality and intelligence measures. J. Persis S. 1990, 54, 617-27. 116 Badcock C. More danger in doctrine than in genetics. Nature 1997, 388, 13. 117 Mayer S. Who report shows public health impact of violence. BMJ 2002, 325, 731. 118 Dawes CT, Fowler JH, Johnson T, McElrath R, Smirnoff O. Egalitarian Motives in Humans. Nature 2007, 446, 794-6. 119 Fowler J.H., Johnson T., Smirnoff O. Human Behavior, Egalitarian Motive and Altruistic Punishment. Nature 2005, 433, 1-32. 120 Boyd R., Gintis H., Bowles S., Richardson P.J. The Evolution of Altruistic Punishment. PROC Natal Academic Sci USA 2003, 100, 3531-5. 121 Seymour B., Singer T., Dolan R. The Neurobiology of Punishment. Nat Rev Neurosci 2007, 8, 300-11. 122 Decay Irvane DJ, Fishbacker U, Trayer V, et al. The Neural Basis of Altruistic Punishment. Science 2004, 305, 1254-8.